Okay, we've been talking about power supplies, we've been talking about semiconductors and their relationship to grounding, bonding, and shielding. What I want to show you here is that if you have objectionable currents, if you have those currents just flowing freely where you're not controlling them inside your facilities, you are going to have destroyed semiconductors. A semiconductor reverse bias, which is basically what we're going to show you here, is having current on the ground side or voltage. It only takes about 200 millivolts to create what's called a breakover. Essentially what's going to happen is the semiconductor, although it may not completely destroy or destroy itself, over a period of time it will be destroyed. It'll quit working. We see this quite often. So I want to show you a couple of things. This is the AC side of a power supply that actually goes in a PC. As you can see, here's the equipment ground, and of course a hot leg and a neutral. Now, as we see in here, we see also that we have the equipment ground that is also common to the case. So if I touch the case and I'm touching the equipment ground that is tied to the case, you can see it is common to it. But also the printed circuit board is common. A lot of folks don't realize that the printed circuit board has continuity because that's how you get your ground reference. And so if I go in, and we're going to do this, we're going to touch the equipment ground now. And then I'm going to touch an IC. As you can see, I'm touching the IC, and you see by the ring that we do have continuity. Therefore, if you get objectionable current through this equipment ground because somebody has improperly grounded the equipment ground into neutral, which all it does really is become a parallel neutral because the neutral is a current carrying conductor. When this occurs, you're going to subject this printed circuit board to objectionable currents that it was never intended to. Of course, then you start winding up replacing printed circuit boards, ICs, etc., etc., etc. And so semiconductors can only keep in mind that semiconductors can only handle about 200 millivolts before breakover starts. That's based on your average germanium or your silicon type semiconductor. So that gives you some information, and again, why we want to control objectionable currents. But we want to make sure that we are not destroying equipment because of the way we are wiring the system. And I see that quite often. The problem with it is, and what makes this seem like everything's fine, is because the rest of the system's working fine. They would never realize that would probably be on their grounding or their bonding or their shielding system. Okay? Hope that helps you.